To Waidsum Academy. Today we are looking at mathematics chapter 20. Topic is function. Now, without wasting time, let's quickly go to the business of the day. Now, function as a mapping machine. Okay, function. First of all, if you consider a linear equation of y equals to 2x plus 3, meaning you can define the domain. The s is the domain, the input signal. So if you key in the input, whatever you choose for input, it will determine what the output will be, and our output is the range output. So whatever input we choose will determine the corresponding output that we're going to get. So such relationship is called function. Such relationship between two variables, variable x and variable y, such relationship between them in which the input one, which is variable x, determine the output one, which is variable y, is called function. It's called the function. So a function is a particular type of relationship between two variables. It has some characteristics that defines such the output. Now, one of those characteristics that define the output is the input variable. So whatever we choose as our input, let's say from -1 to 3 as the values of the input, which is x. If you key any of these values, you get the corresponding output. For example, if your x is -1, then you put -1 here. 2 times -1, you get -2, plus 3, you get 1. So our output will be +1. Our output will be +1. So if this is 0, then if our input is 0, our output will be 3. If you put 0 here, 0 times 2 is 0 plus 3, so y will be 3. If your x is 1, 2 times 1 is 1, 2 times 1 is 2, plus 3 you get 5. So if your x value is 1, your output value will be 5. If your x value is 2, 2 times 2, 4, plus this, you get 7. So if your x is 2, your output y value will be 7. If your x value is 3, 2 times 3 is 6, 6 plus 3, 9. So you get. So this type of relationship is your given x values are your domain, and your output are your range. Your output values are your range. So if you draw a function machine, so you link each input to the corresponding output. This relationship is a one-to-one function. It's a one-to-one function. So this is a one-to-one function which determines what output the domain, which is the input value, determine what the output range is. So this relationship is called one-to-one mapping. This relationship is called the one-to-one mapping. And there are also different other type of functions which are called like many-to-one mapping, where you have many input is being mapped to single output. Many input mapped to the same output. Okay, when you have many input sent to the same output, it's called many-to-one function, like the one you have here. Like you can see, many input can go to one single output. So this type of function is many-to-one mapping. Okay, now that's for function. We should learn how to map a relationship. We should know the domain. Domain are the x value, and the range are the y value. So your domains are the values in the x-axis, and your range are your values in the y-axis. Your range are your output, which is y values. Okay, so we should know this one. And when we give it this like a cubic graph, this is a cubic graph that is plotted. Okay, in this cubic graph, we're choosing a given range of a given domain of values. That's the x value. You chose a given x value, and then you make your table, you key into the function. Look at the equation. Y means f of x equals to x to the power of 3 minus 3x. So we're choosing a given domain from -2 to 3, -2, -1, 0, 1, 2, 3. These are the values of x that you key in. You substitute into this to get the corresponding f of x or the corresponding y values. Once you get the y values you plot, you're going to get a graph like this. You're going to get a cubic graph like this. Is that okay? Overlap or overview, so to say. An overview of a function, the mapping in a function. Function as a mapping machine. Okay? This is many-to-one function. This is one-to-one function. So they can give you diagram like This is one-to-many function. Okay, this is one-to-one function. So they can give you something like they ask you to identify what type of mapping is shown. Now let's go to calculating functions. Okay, in functions, when we're calculating functions, for the function f of x equals to, we are given f of x. This is how we define function. F of x equals to 3 minus 5. Now they want us to evaluate f of 2. So what it simply means, in place of x, you put 2. So this is f of s. F of s has been defined as 3 minus 5. Okay, now they say calculate f of 2. What it simply means, where you have x, put 2. So if you put 2 here, you say 3 times 2, you get 6. 6 minus 5, you get 1. So that's why our answer is why our answer is 1. So what we did is just to substitute. When they say calculate f of 2, put 2 in place of x. You put 2 in place of x. So you're going to say 3 multiplied by 2. Okay, you're going to say 3 multiplied by 2 because it's 3x, right? And they say f of 2. So you say 3 multiplied by 2. I put 2 in a bracket, to show that we are substituting it for x. 3 multiplied by 2, you get 6. Then you say minus 5. So we get 6 minus 5. Then we get 1. 6 minus 5 will get 1. This is how we got 1 in this for this question. This is how we got 1 for this question. Okay, f of negative 2 is the same thing. We're going to substitute negative 2 in place of x. So we're going to say 3 times negative 2. 3 times negative 2, that's negative 6. So negative 6 minus 5, you get negative 11. You're going to get negative 11. So negative 6 minus 5, you get negative 11. So when they say f of negative 2, put negative 2 in place of x. So you say 3 times negative 2, you get negative 6. Okay, negative 6, negative 5, you get negative 11. So that's the evaluation. When they say evaluate, this is what they want you to do. Now, what of f of 0? Meaning anywhere x is, you're going to substitute 0 there. So you say 3 times 0, which is 0. There's 0 minus 5, you're going to get negative 5. See, 3 times 0 gives us this 0. Then this 0 minus this 5, you get negative 5. Okay, get minus 5. So that's how we solve this one. Now let's move on to still solving more. See, f of x can be written like this. You can either write it as the way we used to write it. Either we write it the way we used to write it, or either you write it as f of x, or you write it like this. F such that s go to this. Okay, you can write it like this. Okay, now you'll be given f of s equals to 2x plus 6 over 3. F of s equal to 2x plus 6 over 3. Right? Now, they say find f of 3. Calculate f of 3. F of 3 is just simply to substitute 3 anywhere we see x. So if we substitute 3 here, what are we going to get? If we substitute 3 here, what are we going to get? We're going to get, let's substitute 3 in this place. So they say we should find f of 3. So if you say 2 times 3, we get 6, right? 2 times 3, we're going to get 6. 6 plus 6, 2 times 3, look at the 2 times 3. We substitute 3 in place of x because they say we should calculate f of 3. So you say 2 times 3 plus 6. So 2 times 3, you get 6. 6 plus 6, you're going to get 12. 12 divided by 3. 12 divided by 3, you're going to get what? 4. You're going to get 4. So for this function, we get 4. We get 4. Now, what of f of 1.5? You do the same. 2 times 1.5, in place of x, in place of this x, you're going to put 1.5. So 2 times 1.5, you get 3. 3 plus 6, you get 9. 9 divided by 3, 9 divided by this 3 in the denominator. 9 divided by 3, you get 3. So that's why this one is 3. Is that okay? Now let's move to f of negative 1. Substitute and get f of negative. This one is just this mere substitution. Okay, it's not a big deal. This is just a mere substitution. So what of f of negative 1? So anywhere x is, you put negative 1. So we're going to say 2 times negative 1 plus 6. 2 times negative 1, we get negative 2. Negative 2 plus 6, we're going to get negative 2 plus 6, we're going to get 4. So 4 divided by 3, we get 4 over 3, which is 1 point something. Okay, 1 point something, probably 1.75. Okay, so that's that. Let's take a look at this other one. It says for the function, this is a quadratic one now. For the function f of s equals to s squared plus 4, evaluate s squared plus 4, evaluate for this function, evaluate what you have, f of 2. Evaluate f of 2, meaning we're going to substitute 2 here. So instead of s squared, we're going to say 2 squared. 2 squared will give us 4, and therefore plus this 4, we get 8. So that's how we got 8 here. Now f of 6. So we're going to say, since it's s squared, you're not going to say 2 raised to the power 6. You're going to say 6 squared, because they are saying calculate f of 6. So in place of x here, you're going to write 6. Then you square 6. 6 squared will give you 36. 36 plus 4, you get 40. 36 plus 4, remember 4 is part of the question. 36 plus 4, you get 40. Okay? Okay, let's move on to f of negative 1. So you're going to put, anytime you have negative, you have to bracket it. F of negative 1, you're going to say negative 1 square. If you don't put square, your answer from calculator will be negative 1 also. So which will make your answer wrong, overall answer. So you put bracket and then you square it, you're going to get 1. Minus 1 square, you get 1. 1 plus 4, you get 5. That's how we got this one. That's how we got this one. Is that okay? Okay. Now, so at this junction, pause this video and calculate all of this. Calculate all of this. Substitute. It's very easy just to substitute. Like, for example, you're going to substitute this 2 in this place. So you're going to say 2 times 2, 4. 4 plus 2, that's 6. Finish. That's the evaluation of the f of 2. And so on and so forth. F of 0, you put 0 here. 0 times 2, you get 0. 0 plus 2, you get 2. Is that okay? Okay. So you pause the video and solve all of this. Let's move on to the next one, which is a composite function or inverse composite function. Solve all of these ones. All. Don't. The more you do, the better you become. Okay. Now let's go to the next one, which is inverse. Inverse came first before composite. Or we skip. Okay. Inverse came first. Okay. Let's do the inverse. Now for inverse function, inverse means, function, we say you write function like this, f of x. You write function like this, f of x. This is how we write function. F of x equal to whatever you want to define it as. F of x equal to 2x plus 3. This is how we write function, f of x. We write f of x. That f of x, remember I say it means y. It means y. F of x means y. Now the inverse of it will be what? The inverse will be f raised to power minus 1. F raised to power minus 1. This is the inverse of it. F raised to power minus 1 of x. This is how we write the inverse. Okay? This is how we write the inverse of the function. Okay? So, now, but how do we calculate inverse? There are about 3 rules we need to put into cognizance in order to calculate inverse. The first thing we do, if we want to calculate inverse, is to rewrite the function replacing f of x with y. So instead of writing f of x, the first rule is to rewrite the function and then you replace f of x with y. So instead of saying f of x, you replace it with y. You replace it with y. So instead of saying this, we say y, we say y equal to 2x plus 3. We say y equal to 2x plus 3. That's the first thing we do when we are doing inverse of function. And the function that has been given to you, replace the f of x with y. That's the first thing. The second thing we do, these 3 things that we're going to do, we're going to like keep them in mind so that every time they ask you to do, you remember to do. Interchange x and y. That's it. That's the next thing. Interchange x and y. That's the next thing to do. Right? we're going to interchange. What do we mean by interchange? Swap their position. Where x is, remove x and put y. Meaning here was y, right? I'm going to write x in place of y and put y in place of x. Interchange. Change their position. Just take x, put x here. Take this y, put it here. That's it. That's all. You're not doing anything. Just this y, put this x, put it in this place. This y, put it in this place. Every other thing is the same. So meaning we're going to write like this. We're going to write here, replace, interchange the position. Here will be x equal to, instead of 2x now it will be 2y. Will be equal to 2y plus 3. With 2y plus 3. Remember what we are going at, where we are going. We want to find the inverse of the original of this original function, this one. We want to find the inverse. We want to find the f of x. Then the next thing is to make y the subject. Rearrange the equation to make y the subject. That's the next thing to do. The next thing is to rearrange the equation to make y the subject. So we go to rearrange the equation to make y the subject. Rearrange the equation to make y the subject. So which means we're going to make y the subject, right? We're going to make y the subject. To make y subject, I move 3 to come and join x. I leave the 2y here. So this will become what? X plus y. No, x minus y. You know, when 3 comes this way, sorry, x minus 3. When 3 comes to the left, it's going to be negative. So here we have x. When 3 comes to join it, you leave the right side to come to the left side, it's going to be negative. So it's going to be x minus 3 equal to 2y. Equal to 2y. Now, because you want to make y the subject, you divide both sides by 2. Because you want to make y the subject. So divide here by 2 and then divide here by 2. So when you divide by 2, you see your new y will be equal to what? Will be equal to x minus 3 over 2. Will be equal to x minus 3 over 2. Now you see this is different from the first y, the first assumption of y you made. X minus 3 over 2. You can see this is different from the first y you made, that this one. Since it's different, then it means this y is the inverse one. It means this y is the inverse. So you write the inverse f raised to power minus 1. This y is no longer, you know, the first assumption was let f of x equal to y. That was the first assumption. Let f of x to be equal to y. Now, if you see, this f of x is now equal to y. So y was equal to this. Y was equal to this. So if you reach this point, you see what you have gotten now is different from y. So it means it's the inverse. So you say f inverse of x equal to what we just obtained. Is equal to x minus 3 equals to x minus 3 over 2. X minus 3 over 2. So finish. That's how we solve inverse function. 3 rules. First, rewrite the equation replacing f of x with y. You must remember these 3 rules. Write these 3 rules down. You have to write them down. If you don't remember these 3 rules, you will not be able to solve the inverse. Although, for someone who is experienced, you can solve inverse even without this thing, the shortcut. You can solve it. Okay? But if you are not experienced, you will not be able to solve it. So rewrite the function, replace. The first thing is to replace f of x with y. The second thing is to change the position of x and y. The third thing, make y the subject of formula. These are the 3 rules. And you must keep the rules in your head. Okay? Commit them to your memory. Okay? So that every question you give, like for example, look at this one. They've just given us this function. F of x equals to f of x equal to x plus 2. Now, the first rule is that we should change this one to y. Change this one to y. So I will write y equal to x plus 2. We are not changing anything here. Only this one. Change f of x to y. So y equals to x plus 2. Then, rule number 2 is that interchange their position. Bring x here and bring y here. So I bring this x, I bring it to this y position. And I bring this y, I bring it to this x position. So it becomes x equals to y plus 2. Then after that, make y the subject. Make y the subject. Meaning move this 2 here to this side, become x minus 2. So y will be x minus 2. This is the inverse. So this y, you can see this y is different from the original y, because the original y was y equals to x plus 2. Now this y is equal to x minus 2. It therefore means the opposite is the inverse. So you say the inverse f of s equals to x minus 2. So it's as easy as that. It's as easy as that. Okay. Now let's take a look at the second one, g of x, because they can use g of x, h of s, k of s, whatever letter they want to use. Okay, whatever consonant they want to use, they can use. G of x is the same thing, whether they say f of s, g of x, blah, blah, blah. Okay, now g of x equals to 2x minus 2. Find the inverse. So what we say, replace this g of x with what? With y. So it will become y equal to 2x minus 3. Y equal to 2x minus 3. That's it. Then the second rule says it will change the position of x and y. Put x here and then put y here. So it becomes x equals to 2y minus 3. Every other thing stays the same first at the moment. Then the last rule is make y the subject. To make y the subject, first move this negative 3 to come and join x. So that, because we want to make y the boss. So move this negative 3 to come here, it becomes x plus 3. If it comes to the left, this negative 3 comes to the left, become plus. Become x plus 3, then divide both sides by 2. To divide both sides by 2 in order to find y. So y will be equals to x plus 3 over 2. You can see this y is different from this y, assumption we made here. Therefore, this is the inverse, the opposite. So you say g inverse. When you want to write inverse, you write the letter they gave you, raised to power minus 1 of x. So this is g inverse of x equals to x plus 3 over 2. So meaning you found the inverse. Is that okay? Are you following? Okay. So we assume the student you are following, okay? So the global student. Now let's take a look at this one. If f of x equals to x minus 3 over 3, calculate f inverse of 2. Now, this one, they are not just asking you to find the inverse of this function. Yes, you find the inverse of this function, and then you substitute 2 in place of x after you found the inverse. After you found the inverse, you substitute 2. So that's the meaning of f inverse of 2. First and foremost, you have to find f of x of the function. Now, to find f of x, you replace this one with what? With y. Replace this f of x with y. We replace it with y. So we replace f of x with y. We have this y equal to every other t is same. We write x minus 3 over 3 as it is in the question. Then the next is change the position of x and y. That's the second rule. So meaning I put x here, I put y in this place. So it becomes x equal to y minus 3 over 3. X equal to y minus 3 over 3. So then the next thing, make y the subject. To make y the subject, you cross multiply. This one will be 3x equals to y minus 3. So 3x equal to y minus 3. 3x, if I cross multiply. The meaning of cross multiply is, or you say multiply both sides by 3. Either you say cross multiply or you say multiply here with 3 and multiply here with 3. The 3 here, we cancel this 3 at the bottom. So here will be 3x equals to y minus 3. 3x equal to y minus 3. So remember, we want to make y the subject. So you move negative 3 to this side, become 3x. So you can write y. If you like, you can write y first equal to, you assume that you are moving this one to this side. So it will be 3x plus 3. 3x plus 3. That's what y is. So since this is different from the original y, this was the original y. It means this is the inverse. So you write f inverse of x. F inverse. Inverse means raised to power minus 1. F inverse of x is equals to 3x plus 3. It's equal to 3x plus 3. 3x plus 3. Okay, is equal to 3x plus 3. Now this is the inverse. We calculated the inverse. But remember they say find the f inverse of 2. Meaning we're going to substitute 2 here in place of x. So I'm going to say 3 times 2. Instead of 3s, you say 3 times 2. 3 times 2 because they say find f inverse of 2. 3 times 2 plus 3. 3 times 2 plus 3. So 3 times 2 you get 6. 6 plus 3 you get 9. Right? Right? So here we get 9. This is equal to 9. So that's what they got here. That's what we got here. That's what we got here. 9. This is how we got this 9. Now f inverse of minus 3, meaning you put minus 3 here. So minus 3 times 3 you get negative 9. Negative 9 plus 3 you get negative 6. So this one will give you negative 6. Okay, so that's how to do inverse function. So I hope you already understood how to do inverse. So you pause this video and solve all this one. Change and find the inverse of these following functions, and also find the inverse of a number, inverse of 0, inverse of f, inverse of 2. First you find the inverse of this, then you substitute 2 in place of x, okay, and so on and so forth. So now we go to the last but not the least, the composite function. Now what is a composite function? It means two functions that are embedded into each other. Two functions that are joined together and put into each other. So in this case, they're going to give you f of x equals to x plus 2, and they will give you g of x and g of x. Then they will tell you to find f g of x. F g of x. This one we do it like the way we do bearing. Okay, like you start from the right, you substitute the one on the right to the one on the left. You substitute the way you read Quran. Okay, you substitute the one on the right. You know, we read Quran from the right to the left, right? So it's the same way you do this one. You substitute the one on the right and put it on the one on the left. The same way you do bearing. I mean, when they say bearing of A from B, when they give you bearing of A from B, you remember when you're doing bearing, when you want to calculate the angle from the north, what do? If they say bearing of A from B, meaning you go to B, you go to the cardinal point of B and do it to the line going to A. You go to the cardinal point of bearing of B and do it to the line, draw it to the line, do the angular measurement to the line going to A. Okay, when we reach bearing topic, we are close to bearing already. When we reach bearing topic, we're going to do that. For composite function, anyone that is the rightmost one is the one you substitute on the one on the leftmost. That's just the secret. For example, g of x is the rightmost. You're going to substitute this whole x plus 3. You're going to substitute it in place of x. You're going to replace only this x with x plus 3. So you're going to take the whole of this, g of x, and put it here, in place of x. You get it? You get the jax? You're going to take the whole of g of x, this whole of g of x, this one. You're going to put it in f of x. You're going to put it in f of x. You take this and put it in f of x. The whole of this, put it here. When you put it in here, you put it to replace the x. You replace the x. So look at the function. So you're going to take the whole of g of x, which is x plus 3. You use it to replace this x. So you're going to put it here. Instead of writing x plus 2, you put this x plus 3, the whole of g of x. You use it to replace x. Then before you say this plus 2, before you say plus 2. I hope I made that clear. Instead of writing x, I'm going to write x plus 3. Instead of writing x in f of x, I'm going to write x plus 3. Then, before I add the 2, before we add these two. So now what you have is x plus 3 plus 2. So 3 plus 2 is 5. So our fg of x becomes x plus 5. So your job is done. Now let's move on to the next question. You are given f of x equals to 2x minus 1, and g of x is x minus 2. Find f g of x. Meaning we still go to substitute g of x in place of f of x. Anywhere we see x in f of x, we take the whole of g of x and put it inside. Okay, so what is our g of x? Our g of x is x minus 2. Now this x minus 2, I'm going to put it in this position only, position of x. So instead of writing x, we're going to take the whole of x minus 2 and put it here. So our fg of x will now be, fg of x will be equal to fg of x. Our fg of x will be equal to, take the whole of this g of x, x minus 2, and put it here. So I'm going to write 2, then open a bracket. You know there's 2 here first in f of x. There's 2. Then you open a bracket to put the whole g of x in this position. So we open the bracket. You can open bracket like this. Take the whole of g of x, put it inside that bracket in place of x. Substitute the x minus 2 and use it to replace this x. So I'll write x minus 2 in this bracket. X minus 2. Okay, after doing that, then I'll say minus 1. This minus 1. I put the minus 1 here. And then I simplify what I have. Just simplify. In this case, you go to expand. So 2 times x, you get 2x. You get 2x. 2 times x, we get 2x. 2 times negative 2, you get negative 4. Don't miss the sign, okay? 2 times negative 2, you get negative 4. Then negative 4, negative 1. You put this negative 1. Negative 4, negative 1, you get negative 5. So our final short will be 2x minus 5. 2x minus 5. This will be our composite function. This will be our composite, which is fg of x. Our fg of x is 2x minus 5. Fg of x. Okay, this x, remember, is always in bracket. Fg of x equals to 2x minus 5. That's how they got this 2x minus 5. That's how they got this 2x minus 5. Okay, this is how we got this 2x minus 5. Now let's take a look at this one. You are given f of x equals to 2x plus 3 and g of x is 2x. Evaluate fg of 3. Fg of 3. There are 2 ways to do it. It's either you do the composite first, then you substitute 3, or you substitute 3 in g of x. Whatever you get, you substitute it in, the answer you get, you substitute it in f of x. In additional math, what we do is we just use the later, the one I just explained last. We just take 3, put it in f of x, meaning take 3, put here, this will be 6. 3 times 2 will be 6. And then you take that 6, come and put here. 2 times 6, 12. 12 plus 3, you get 15. That's how we do it in additional math. Which is, to me, is easier. The additional math trick is faster and is easier. We just take this 3, we put, it's the same thing, okay? Any method you want to use is the same thing, okay? You take this 3, put here, put in g of x. In place of g of x, take this 3 and substitute in g of x first, which means 3 times 2, you get 6. Then the whole of g of x, which is 6, take it and put it here. So 6 times 2, 12. 12 plus 3, you get 15. Okay, but in this ordinary mathematics, IGCSE mathematics, this is how they did it, which is another method. So it's up to you as a student which one you want. You first of all substitute this one, the g of x, into this one. So which means we get 2 into, you open the whole of your g of x, take this 2x, replace x with 2x. So it becomes, you substitute 2x here, okay, plus 3. For the way you get your normal composite, you get your composite. After getting your composite, these are the type of questions that will be in the exam. Okay, after getting your composite, you get 4x plus 3, right? If you expand 2 times 2x, you get 4x. You get 4x plus 3. Then after you get this one, before you substitute the fg of 3, before you substitute the 3 that has been given to you. So you take this 3, put here, it becomes 4 times 3. 4 times 3, which is 12. Then 12 plus 3, you get 15. So whichever way you want to do it is okay. Whichever way you want to do it is okay, as long as you get the correct answer. So in additional math, but I feel the additional math way is easier. We just take the 3, put here, 3 times 2, 6. Take the 6 we got here, put here. Put in this x position. Okay, it becomes 2 times 6, 12, 12 plus 3, you get 15. Okay, so this is it. So at this junction, pause the video and solve all of this one. Solve all of this. Pause the video and solve all of this one. Okay, solve them. The more you do, the better you become. If you want to pass your Cambridge IGCSE without stress, you have to solve a lot of questions. This student assessment. Every chapter, you have to solve all the student assessment. Any chapter you don't do the student assessment, it means you did not study that chapter. That's what it means. Student assessment 1, student assessment 2. In fact, some chapter has up to 4 student assessment. So this one only has 2 student assessment. So with this, we've come to the end of our today's class, and thank you for joining us.